Start out with, are there any questions? Brittany, did you still want to wait to ask your questions, or?
Okay, so I had a question about number 7 on the lab that we did yesterday.
And I do not have it in front of me, so which one was number 7?
What would the bounce coefficient of 1 have physically, not mathematically? Would it be possible for a ball to have a coefficient greater than 1 not? I'm assuming that if it had a coefficient of 1, that the bounce height would be the same as the drop height.
Yep.
And then if it was higher, it would be a higher bounce height. Okay, I guess I have a couple of questions about that. Are you asking like what aspects of physics would make the bounce coefficient
All right.
of 1 or?
So the bounce coefficient you got for the 2 balls you did came from the slope of the lines. What I did not want is for someone to say a bounce coefficient of 1 means the slope is 1. That's what I meant mathematically. What you told me physically, that the bounce height would equal the drop height for 1, that's what that's the type of answer I was looking for there.
Okay, and then to the second part, are you just referring to dropping the ball, or are you referring to putting extra force on the ball to make it more than 1?
You're dropping. If I drop the ball from here, could it bounce higher than the,
That would have to be a really bouncy ball. I don't know if that really would happen.
there is actually a word for a ball that would do that,
Okay,
flubber.
okay,
So that, it's science fiction right now.
okay. All right, okay.
Or is it?
That's it for that one.
Sorry, Elaine?
I think Mike's son had a sky ball. I think those suckers go higher than the point where you drop it, but.
Yeah, and usually,
I think.
when I've had balls like that, I usually throw them down, so yeah, they do bounce a lot higher.
I'll have to look.
If you find it,
I will.
and it does, bring it in. Yes.
I also had a question about number 11. Will the trend show on the graph between bounce height and drop height be accurate or somewhat accurate indefinitely, or will it fail at some point in life? Are you referring to that the bounce height would eventually be like consistent after? a
Wait, sorry,
certain height?
I lost it near the end there.
I'm sorry, are you referring to like how the bounce height may just become like consistent after a certain amount of height, or, I don't really understand.
All right, so let's assume really nice data and you do your points and they're all really linear. And so you've got a line going like that. So this was bounce height, drop height. Does it level off at some point? I mean, are we going to maintain this? So if I drop it from 1,000 meters, is it going to be, well, I just go up to the line, then go over, and that tells me how high it's going to bounce? Or is it going to level off at some point? So, I mean, is it going to do something like that? Or actually probably more like the other way? Or is there some other thing that should be taken into account the farther up you go?
Maybe like air? Like
At,
air?
at some point, that's going to cause it to have an effect.
So just explain that.
Yes.
Okay.
Other questions?
And just to make sure that I
Okay.
understood you correctly, when you were telling me how to find out the predicted bounce height, I plug in our actual bounce height as X,
Correct.
and then that will give me the predicted bounce height, and
Yes,
Okay,
absolutely.
thanks.
You have a look on your face like you want to ask a question.
So many. I think I'll have a lot more than that. I'll need to get that far. Yeah. I've got the graph, and I'm proud of myself for that.
All right.
That's about as far as.
Oh, okay. So you're just gonna leave it hanging out there for right now and you'll?
Yeah, for now, and then
Okay.
yeah, sorry.
Okay.
Thank you.
I'm not trying to force you to ask, I'm just
No,
giving you
you're
the
fine.
opportunity. Any other questions right now?
How do you
Hannah.
do the prediction?
Sorry?
How do you do the prediction for the graph?
How do you do the prediction?
Yeah.
All right. So there's the official way and then there's the, I hope I drew it correctly way. So let's go through the official one first. So you're using a computer, you got your data points right here. You do add trend line and it gives you a trend line. You click the show the equation, show the R² value. So you end up with something like f of x or y equals 0.532 x plus 0.107. Obviously just making numbers up, r² is equal to 0.998. So what this equation is saying is that if you think back, flash back to math class, y equals mx plus b, the slope intercept form of the line. Except I really don't like using m for slope because we use m for mass in meters and it's enough. So oftentimes for slope, I'll just use a $sign. So my slope is this 0.532, my intercept is 0.107. And what this equation is officially telling us is that if we did it perfectly, we would expect all the data points to fall on this line. So this was bounce height and drop height. So to find the prediction, I just have to figure out, so for whatever drop height you picked, and let's just, for this example, let's assume that you dropped it in part C at 0.9 meters. That's an M there, in case you can't read my handwriting. There, much better. So let's say that's your actual drop height for that last part. So wherever 0.9 meters is, you want to figure out what is the corresponding value over here. So you plug it into the equation. So this value right here should be 0.532 times 0.9 plus 0.107. And that's how you would do it for the math fans. That's how you would do it. And then the other, I hope I drew it correctly, that if you're doing this by hand, if you don't have the equation, then you would actually, you've drawn your line, you go to 0.9, you come up here to wherever you hit the line, and then you come over and you see where it hits.
So do we need to show all of that math to get full credit for the prediction?
What the wording I said is what show your work.
Yes.
You could just say plugged into equation if you did that.
Okay.
If you did the more visual
Right.
version of it, then it'd be nice to see the dotted lines.
Okay.
Because what I'm gonna do is, I input your data into a spreadsheet that I have, and it automatically calculates doing this way. If it disagrees with that,
Right.
I'm gonna look at your graph, and then I'm gonna follow it and see, do I get even close to what you had?
Yeah.
And if not, then I'm
Okay.
assuming you did something strange. Not showing work generally makes things at all or nothing kind of.
Right. And what about the percentage? How do we calculate that again?
All right. Percent error and percent difference are two things that are going to show up quite a lot in this course, in labs.
Esther, I have a sheet that Ms. Dawson gave me. They talk about percent error and percent difference. I can make copies and bring it to everybody.
Okay. Or if you send me, do you have a electronic version? Okay. If you bring it, I can make copies. There's also under the, for the lab part of the course, if you go to coursework, lab manual, there's 2 documents there, which go into it as well. I've just changed them this morning, so hopefully they're a little bit clearer. There are more words in it. Hopefully that makes it better. That tends to be my reaction to trying to clarify things, is to put more words in, which at some point really starts defeating the purpose, but it's still my go-to. So in this one, percent difference and percent error. I believe on this lab we're doing percent errors. Both of them are ways of comparing 2 numbers. So for percent difference, we're comparing 2 numbers. We have no idea what the correct answer is. We don't have any prediction. We're running an experiment, and we get these 2 values. I don't know if one's right or not. That's why the word error is not here, is because we don't know what we're shooting for. We're just coming up with a value. So here, compare 2 values. The correct value is percent error. The error is in there because we're saying there's a mistake. Something is not matching what we were expecting. Now, what we're expecting in some cases is theoretical. Some case it is just an accepted value because there have been enough other people who have done the experiment and this is what the accepted value is. And there are a few cases in which you will come up with 2 values and you'll go, well, this technique was kind of questionable. This technique I have a lot more faith in, so I'm going to go assume that this is actually the correct value. So in our particular case, we're doing percent error, and we're assuming that the predicted value is correct. That any error that you might have had in your experiment sort of the errors get washed out when you do enough of them. So in either case, you find the difference between the 2 numbers you're comparing. So in this case, if you have prediction of 73 centimeters, and then you run the experiment and you get 65 centimeters, you'll take the difference between the 2, whatever you make absolute value after you've done the subtraction, and then you divide by what your target is. So you would divide by the 73. That'll get you some decimal, and then to put it in percent form, you multiply times 100%. Or on a calculator, you're multiplying by 100. Or you move the decimal point over 2 spaces. Yes? But,
Is it possible that, can you hear me?
yes?
Okay. Is it possible that the group did not have the same like prediction stuff as you, like the percent error came out different? Because that's kind of
It is possible. Now, the reasons I would assume that it actually is going to be close, but not exactly the same. Where I would see differences showing up is when you did the 5, for each drop height, you did 5 bounces, and then you averaged. Some people would round off that average, some people don't, so that's going to be one place where there might be some discrepancies. Because those data points are then going to be put on a graph, and then you'll get a line. Now, if all of you use the exact same numbers for your data points, and you let the computer figure out calculate what the equation is, I would assume that the only differences at that point would be how the computer rounded. Because I know that some spreadsheet programs they'll give you 10 decimal places, and Excel, I think, flips a coin and decides how many it's going to give you this time. So there might be some differences in the number of decimals it takes.
okay, but I'm not really referring to the first 2 balls. Well, yeah, but the second ball on this part C.
Right.
Yeah, that's what you're. I'm sorry.
Because if you're using the equation to make the prediction, if your equations are the same, your predictions, I would think, would be the same.
Right.
Now, another place where partners would have different answers would be if somebody did it by hand. and someone used it by computer, or two people did it by hand. If you did it by hand, then there's a certain amount of close enough that I'm expecting.
But would it, what am I trying to ask here? So would it be acceptable even if they're, like, if they were close, but they weren't exactly the same? Like, should the data, because I know you said our data should match, but like, the evaluation part should be different, but, would it tax one of us or all of us, or if either one of us had, what am I trying to say, sorry. Should the data be all the way through, like, matching?
Anything measured directly in the lab should be matching.
Okay.
Anything that's calculated, so the prediction, the graph, any of that stuff, there might be some variation, which, if somebody came out with 4% and somebody came out with 5%, I'm not automatically thinking, oh my gosh, there's a mistake somewhere. Maybe there is, maybe there isn't. I'd have to look at your specific paper just to see how you got there.
Okay.
If somebody came out with 5% and someone came out with 15%, that's the point where I'm going, yeah, there's probably one of those two people did something strange.
Okay.
That, have I answered your question well enough?
Yes.
Okay. It was not a confident yet, but yes. let
And
me know.
you have to do that first to do that, right?
Yes, you need to have the graph to make the prediction, and you need to have the prediction in order to do this.
And you came up with the 0.9 for the X by yourself?
That 0.9, I just made up a number, that's your actual drop height.
Okay.
I think in part C, that's the first blank, is the,
Mhm. And then we should all have the same exact graphs, right?
Yes. I would think so, or very close. Again, it comes down to, you're plotting that average bounce height from each drop height. So if somebody rounded when they came up with the averages, it might be a little bit different, but they should look very similar to each other.
Okay.
If you come out with equations and one, let's say that this was the equation that you got, and one of your lab partners came out with, say, 1.9, yeah, there is something very wrong there. Matter of fact, in that case, if somebody came out with 1.9, they probably got the numbers backwards. Tana?
Yes,
Okay.
Can we use any other software besides Excel?
Yes.
Okay.
Oh, absolutely.
Okay.
Matter of fact, some extra bonus points in here if you badmouth Microsoft. Elaine?
Learning Microsoft again.
Such
and
joy.
Again and again and again. You said the decimal point, you said that it didn't matter how many, because I thought I saw, or does it matter? Because I thought I saw in one of your instructionals where it said 5 decimal places, and so I just wanted to, if that was.
Yeah, I think 5 is good.
Okay.
What I don't, if it comes out automatically with a 4, I'm,
It was at a 2, and so I figured out how to do it.
okay. Yeah, what I don't want, there's a lab in particular that I do with, in Physics 152 and 252, where for whatever reason, Microsoft gives one significant figure, and it comes up with very drastic final results because of that. But if you take it out several decimal places, or several significant figures, you actually get very good results. So that's where that comes from. What I don't want is just one decimal place.
Okay.
The place I think I said to 5 is if you get an R² value of 1, that's the point where that better be 1.00000.
Okay.
That's the point where you need 5 decimal places, because R² is equal to 1 usually means either there's bad rounding going on here, or you somehow messed up the data and for perfect results.
Okay, okay,
This makes me very suspicious.
okay. I'm just excited I understood that.
Yeah, physics, there are times in physics where I think, why does anyone believe this stuff? Because the experiments always come out so badly. There's certain experiments that come out really badly. And So R squared is equal to 1 is a red flag for physicists because we really don't expect perfection. So if you are perfect, that might be a chore for you to sort of make a few mistakes. Yeah, you know what I'm talking about, Latoya. All right. Any other questions right now? Yes?
Can I ask more questions after class?
Yeah?
Great, thank you.
This part relates to the syllabus, but when do we have quizzes? Do we, like the quizzes, sorry,
Yeah, the master sets will count as quizzes. That's gonna be the primary place for quiz grades. I've done in the spring was the first time I had the 8-week version of 110, with basically with a setup where I had part face-to-face, part online. And I started out doing the normal chapter quizzes that I had been doing, and at some point, time just didn't really allow for that, because sometimes quizzes take a lot longer than I wanted. So I sort of abandoned the normal chapter quizzes. So if there is going to be a chapter quiz, you would know in advance. And when we're done with a chapter, or officially done with a chapter, I would say, all right, now we're going to decide when the quiz is.
so really all we have to worry about is already on the syllabus, like there's no other quiz or testing or.
You would know in advance. And I have to put something down on that syllabus. I would really love just to go into a course with absolutely no deadlines whatsoever, and then we'll just figure it out as we go, because coming out with a schedule before you know what kind of students you have is, to me, just ludicrous. But we are required to put down due dates.
And pertaining to that, the master set, is that the MS on the schedule?
Yes, it is.
Oh, good, I found them this morning and started freaking out, I thought I missed something, okay.